not going to do my math homework.
So yesterday we learned about the value k and what it does to the parent graph. We learned that if we add a number on the outside, that it will move the graph up. It'll move the vertex's y value. And if we subtract a number, it moves the vertex down. So, one little shorthand way we could do here to try to remember this would be, we could say, if it's plus, it's going up. If it is negative, it's going down. So we're going to start saying that the outside tells the truth, because when it's adding, it moves up, and when it's subtracting, it moves down. And hopefully we'll see why that is here in a few minutes. We also played around with the a value. We changed it from 1 to -1. And we saw when we change it to a -1, it would reflect over the x-axis. We also saw that the range is dependent on that a value as well. We saw that if a was positive, it would have a minimum value and open up forever. And if a was negative, it would have a maximum value and then open down forever. So let's go ahead and move on to today's topics. So today we're going to talk about the h value and what it does to the graph. So if we remember what our parent graph looks like, y equals x squared, we have a vertex at 0, 0, over 1 up 1, over 2 up 4, over 3 up 9. We need to make sure we're remembering how this growth pattern occurs. So what happens if we subtract 3 on the inside there? If we have x minus 3 quantity squared? Well, hopefully we won't think that it moves up or down, because the k value controls the up and down movement. So what I'm going to do is I'm going to show you guys the graph of this. So the blue graph is the parent graph, and the red graph is the x minus 3 squared graph. So notice that if we look at our vertex, the parent graph is at 0, 0. This one's at 1, 2, 3, 0. So that number inside looks like it moved it right. So the one thing we need to be really careful with is that the inside always lies. We always move in the opposite direction than what the sign actually is. So -3 actually means we're moving to +3, because if we plug in a +3 into our equation, notice how we get out 0. So that's something to keep in mind. The inside always lies. The outside always tells the truth. So if we want to make a table of values here, we should be able to do this fairly easy. We're going to use what we know about our parent graph to figure out what our new values are for this transform graph. Do the best I can here, draw right on this. So we know our new vertex is at 3, 0. We just found that. So we need to be able to go backwards a couple, and let's go forward a couple. Remember, we'd go over 1, up 1. So if we go over 1 from 3, we'd be at 4, and then we have to go up 1, so we'd be at 1 now. So we can reflect that point across the vertex. And then if we go over 2, we need to go up 4. So this would be up 4 now. So now we don't even need a calculator to come up with our ordered pairs. We should be able to discover them all on our own from what we know about these graphs. So let's go ahead and take a look at this problem here. We've got x plus 2 squared. So we saw that when it was negative, it moved to the right. So since this one's positive and the inside always lies, it's moving to the left. So we need to go to the left 2 units. So I go back to -2, and I put a dot. So I go back to -2, and I put a dot. And again, I know my growth pattern. The a value is 1, so we're opening up, so I go over 1, up 1. I put a dot. And then when we draw our axis of symmetry here, we also have this idea of axis of symmetry here that hopefully we're familiar with. I'll draw it on here just to remind us. It comes down where the x value of the vertex here. So now we can reflect these points over. So I'm going to flip this one over to here. Now when I go over 2, I can go up 4. 1, 2, 3, 4. I can reflect that point over as well. Now if I go over 3 for my vertex, I need to go up 9. I don't have enough spaces here, so this is all we're going to do. So now I'm going to connect my dots the best I can on here. So now we have our graph. So let's talk about what is the domain here. What is the domain? Well, does it keep opening up back forever? Does it go forward forever? Yes. So the domain is going to be from negative infinity to positive infinity. But what about the range? Do we have a minimum value or a maximum value? It's opening up, so we have a minimum. So we start at 0 in our y values. Notice our lowest y value is right there, which is at 0, and it will go up forever. So our range is from 0 to infinity. So let's go ahead and take these two pieces that we've learned about and put them together. So if we look at this problem here, notice we've got a -2 on the inside and a -5 on the outside. The outside tells the truth, the inside lies. The number on the outside is what moves it up and down, and the number on the inside is what moves it left and right. So let's start with the number on the outside, -5. That means we have to go down 5 units. And now the -2 is telling us that we need to go right 2 units. Remember, the inside lies. So we go down 5 units and right 2 units, and we can put a dot. So there's our new vertex. So now, again, the a value is 1, so it opens up. And now we can go over 1, up 1. And we can flip that point over using the idea of symmetry. And we go over 2, we go up 1, 2, 3, 4. And put a point right there. And we can flip that right here. Now we go over 3, we need to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can reflect that point over as well. And now we can connect our dots. Hopefully I'll get better at this. Alright, so notice now, we actually can see 2 solutions on this graph as well. Looks like a little bit below 0 and a little bit above 4. So we can also see a y-intercept here at -1. So we've got a little bit more going on with these graphs since we're moving them up and down and left and right. So let's go ahead and just see what our domain is. Well, our domain, does it still go backwards forever? Yes. Does it still go forwards forever? Yes. So we go from negative infinity to positive infinity. What about our range? Well, the range worries about the y values. We know our lowest y value is at -5, so it starts at -5 and goes up forever. So we go from -5, we include -5, up to infinity. And I guess the next question would be, how can we solve for our roots? If we want to know where these roots are, what can we do here other than trying to type it in our calculator? Well, we know our roots, the y value is 0, so we can say 0 equals x minus 2 squared minus 5. Now we just need to get x by itself, so minus 5. So I add 5 to both sides. And now I've got 5 equals x minus 2 squared. Now I need to get rid of the square, so I take the square root of both sides. I also have to worry about the principal and negative root now. So now I've got plus and minus square root of 5 equals x minus 2. So now I need to add 2 to both sides. So 2 plus and minus radical 5 equals x. So now our first solution is 2 plus square root of 5, which is right here, when it's a little past 4, and then 2 minus the square root of 5 gives us the one that's a little bit behind 0. Con los terroristas! And do the Harlem Shake.